Finally, we get to look at how to use the information from a VOR. This can be presented on one of three different instruments in the aircraft: the radio magnetic indicator, or RMI, the course deviation indicator, or CDI, also called the omni-bearing indicator, or OBI, and the horizontal situation indicator, or HSI. In brief, the RMI shows the relative bearing of the VOR from the aircraft. The CDI shows the aircraft's deviation from a selected course to a VOR, as does the HSI. But the HSI also shows the aircraft's heading and selected track. Let's start with the RMI, which also appears in the NDB lesson. Sometimes it is useful to know the relative bearing of a VOR, and the information can be presented on the RMI. Perhaps you need to approach Oxford on the Daventry 202 degrees radial, or the Honolly 160 degrees radial, or the Compton 351 degrees radial. First of all, you need to know where the VOR is relative to you. The RMI indicates the aircraft's magnetic heading against a fixed heading index at the top of the instrument. Often there are two needles, one wider than the other, which can be tuned to two different beacons, either NDBs or VORs, or one of each. The information from both NDBs and VORs is presented in the same way on the RMI, by showing their relative magnetic bearing from the aircraft's heading. By adding the heading and the relative bearing, the QDM to the beacon is shown. However, the information has to be processed by the aircraft in different ways. This is because the aircraft receives a magnetic bearing already encoded from the VOR, whereas the ADF needle simply displays relative bearing with respect to 12 o'clock on the dial, which is displayed over a compass card showing the magnetic heading. Suppose an aircraft heading is 040 degrees magnetic, and the measured VOR phase difference is 270 degrees, which means that the aircraft is on the 270 degree radial. The equipment computes that the QDM is 090 degrees. It subtracts the aircraft heading of 040 degrees, giving a relative bearing of 050 degrees, which positions the RMI needle 50 degrees clockwise from the heading index. If the QDM to the VOR shown on the RMI is to be converted to a true bearing for plotting, the variation at the VOR station would be applied. Compare this with the case of an NDB bearing displayed on the RMI, where the magnetic bearing indicated is based on the magnetic variation at the aircraft. As the arrowhead of the RMI shows the QDM, so the tail shows the QDR, the magnetic bearing from the VOR, which is the VOR radial upon which the aircraft is positioned. If we compare the RMI and the CDI, each has its merits. The CDI gives precise deviation information when flying along a VOR radial. The RMI gives more information in the form of a continuous display of QDM and QDR. Magnetic heading is also displayed, a considerable asset when homing to a VOR or maintaining track outbound. The approximate relative bearing is immediately apparent in a plan view of the aircraft and beacon positions, which is most useful when flying a holding procedure. As the pointer gives a continuous indication of the VOR bearing, the rate of crossing the radials can be easily assessed. With two needle RMIs, the bearings of two beacons can be simultaneously displayed, which is particularly useful when flying along an airway using one beacon ahead or behind for track keeping, and a second beacon off the airway for reporting a beam. And finally, both VORs and NDBs can be displayed. The second type of instrument to display VOR information is the CDI or OBI. We will refer to it as the CDI. It is the principal instrument used for VOR navigation. If you turn the Omni Bearing Selector knob, the OBS, on the CDI until the needle is in the middle, this will tell you which radial you are on. Here, we see that the CDI is set to the 130 degree radial. As the needle is off the scale, it means that our aircraft is not within 10 degrees of the radial, as each dot and the centre circle represent 2 degrees. If we turn the OBS to the left, so that 260 is selected, we see that the needle is beginning to come in. It is at the 4th dot, so the 260 radial is 10 degrees to the right of the aircraft. As we turn the OBS slowly to set 270, the needle comes to the centre of the dial, which means that the aircraft is on the 270 radial from the VOR. We could have turned the OBS in the other direction. It makes no difference, except that it is the longer way round from 130 to 270. It is important to note that the aircraft can be on any heading and be on the 270 radial. Our aircraft is on a heading of 020. It could have been heading 160 or 220. It makes no difference. It is still on the 270 radial from the VOR. Up till now, we have considered getting a bearing from a VOR, possibly for navigation plotting. However, the main use of the VOR is for tracking. This means guiding an aircraft along a specified radial to the VOR overhead. Tracking is the basic technique of airways navigation and is also used in airfield approach procedures. The important thing to grasp is that VOR radials are from the VOR. So, the 270 radial is the radial that goes from the VOR in a magnetic direction of 270 degrees. This does not mean that you are flying that heading away from the VOR. It just means that you are on that radial. The second thing to grasp is that every radial has a reciprocal radial. That is, the opposite direction. The reciprocal of the 180 radial is the 360 radial. The reciprocal of the 270 radial is 090, etc. In the following scenes, you should recall that track refers to the line on a map that you wish to fly along, adjusted for magnetic variation, because a chart is drawn with true north, whereas your direction indicator indicates magnetic north headings. Inevitably, you will experience wind along the way, and only in still air will your heading be the same as your track. In order to stay on track, you will have to adjust your heading by pointing the nose of the aircraft into the wind to compensate for drift. In our example, let's say that there is a 30-knot wind from the south. The pilot may choose a heading of 080 to compensate for the drift and keep him on the 060 track. If you are flying in still air away from a VOR on a chosen radial, your heading will be the same as the radial. If you fly away from a VOR on the 320 radial, your heading will be 320, and the flag on the CDI will show from. However, if, while flying away from the VOR on the 320 radial, you experienced a drift to the right of track, you would know that there was a wind from the left, blowing you off course. You would need to alter your heading to the left in order to compensate for the drift. So your heading would not be 320, but some other figure, such as 310. Confusion comes when you fly towards a VOR, for example, on a heading in still air of 270. Do you set 090 on the OBI because you are east of the beacon and you appear to be on the 090 radial at present, with the needle in the middle? No. When you fly to a VOR, set the reciprocal of the radial you are on, which will be the same as your heading in still air and on the other side of the VOR. So, if your heading is 270, the OBI should be set to 270, and the flag will show 2. If you were to set 090 on the OBI, this would be an error, as the flag would show from, because all radials are from the VOR, and you are on the 090 radial from the VOR, even though you are flying towards the VOR. Your selected radial must always match your chosen magnetic track. In still air, it will also match your heading. When you have selected your radial, and you are within 10 degrees of it, the course deviation bar or needle will tell you where your chosen radial is. The centre of the dial is the aircraft, and the needle is the radial. There are 5 dots either side of the centre. The first dot is a circle. Each dot represents a 2-degree deviation of the aircraft from the radial. Maximum deviation is 10 degrees. Any more and the needle goes off the scale. When we look at the instrument landing system, which we will cover in more detail later, we see that each dot now represents 0.5 of a degree, as the aircraft is so close to the beacon. You must be within half-scale deflection, that is 1 1/4 degrees, to be considered as established on an approach procedure. The VOR needle is a command instrument. If the needle is to the right of centre, you must fly right to get to that radial. If the needle is to the left, you must fly left to get to the radial. Frequently, a pilot may be required to fly towards a VOR station along a specified radial. We'll assume that this is the 270 radial in this example. However, let's also assume that he is currently on a completely different heading, 045 degrees, and is crossing the 240 radial of that VOR. Remember that you need to select the same radial as the track you are intending to fly. So in this case, the pilot selects the 090 radial, not the 270 radial, on his HSI. The deviation bar will be deflected in full, as the 090 radial is more than 10 degrees from his current position, on the 240 radial. When he comes within 10 degrees of the 270 radial, the deviation bar will start to move towards the centre. If he is on the 265 radial, the deviation bar will register 2.5 dots deflection, as each dot is 2 degrees. As he gets closer to the 090 radial, he will turn gradually, and when the bar is centred, he will have a heading in still air of 090 degrees, and a 2 indicator on the dial. The third instrument to display VOR information is the HSI, or Horizontal Situation Indicator. It combines several functions, and, as its name suggests, It provides greater situational awareness to the pilot from one instrument. The HSI shows the track or course selected. For example, the 004 radial to a VOR. It will show the heading selected. Here we see that the heading is 360 degrees, and it will show the deviation of the aircraft from the selected radial to the VOR. The HSI may also show the distance to the VOR. An electronic HSI may be able to display other information, depending upon its sophistication, such as terrain, weather, or the proximity of other aircraft. We have now seen how to select a VOR radial for various purposes, how to interpret the CDI and the to and from flags, and how a VOR is presented on an RMI and HSI.